All right, so I'm going to take a little different take on space. Most of you are for investing or industry or building stuff. I'm more about ideas and thinking into the future and how we will actually survive. Do you have my slides? No. There's no pictures. Well, anyway, all right. So anyway, the background here was SpaceX, okay, and it's Mars colonies. So if you just want to envision that. So I'm going to just give you all the words here. So when we go to space, what we are going to need is a bioregenerative system to grow food. Not necessarily hydroponics or aeroponics. People want to touch plants. People want to work with the soil. People want to harvest their food. You're not going to survive on a salad. I'm not going to survive on a salad. I need meat. I need something that's going to fill me up. I need something that's going to give me energy. It's something that's going to allow me to think. But the keys here are abundant water and nutrients. So what we can do is we can tap in situ sources, either Martian sources for water and NEO resources, near-Earth object, or asteroids. So I guess they'd be MEO, Martian Earth, or Martian, near Martian objects, to get this. So there are some pros here for Martian soils. They're mostly basalts, so those are volcanic soils. But you can see what those are. They have a lot of elements that are good. But the cons are there's low nutrient bioavailability, and they don't hold water very well. Also, the Martian atmosphere is a problem. It sterilizes stuff from photocatalytic oxidation, and it's poisonous, sulfates and perchlorates, so plants don't grow well. So there was a study that was done here in 2022. I'm not sure if you can see. It's at the bottom of the screen. And they grew some lettuces and some turnips, and turnips are on the right, the radishes there in the middle. And they did that through some bioremediation techniques. But that's not what I want to eat. And I'm sure that's not what space settlers are going to want to eat either. For those of us who have had many dinners here this week, we start out with our little salads, and they all have tiny little radishes and lettuces, and no. All right. So here's the black gold. This is what you see here for the picture. That's a sample of CI1 soil simulant that I use to grow plants. And the meteorites, the CIs and the CMs, are abundant in minerals, rare earth elements, and they all have bioavailable nutrients that we can use in agriculture. So if we can harness one of these bodies, 1 meter or 2 meter, not the kind that I showed you yesterday where you're all going to die, but the smaller ones, and bring them to the Martian surface or bring them to the lunar surface, we can use that soil to grow food. So I did a pilot study here a couple years ago with just the simulant itself, trying to answer the question, can we grow plants? Okay, so yep, we can. It needed a little bit of work, but we found that it was had a couple of deficiencies. It was subject to compaction and crusting, and the plants suffered from drought stress. So I thought, there's got to be a solution to this, right? We got to have a solution. So what I wanted to do was think of ways that I could turn that dead soil into a living organic soil. I've already pointed out that that the crops that we have now are just salads. So what I thought about was how to introduce organic matter, improve the structure, improve the nitrogen. And I thought, well, cover crops, right? So some green manure. Professor Fevig this morning worked with the kids. They put a balloon up with the hairy vetch. I chose winter hairy vetch because it's a cold cover crop. It can survive through the winter as a start to start working this soil. And then I thought about the three sisters. That's the corn, Mandan bride corn, Hidatsa Arikara squash, and the Hidatsa shield figure beans. And I made some contacts with the three tribes and permission to use their bean or their seeds from their heritage bank with students. So we're going to do this companion farming, and those are the three. Oh. So they would be starting from scratch, settlers on other worlds. So you're going to be manual labor reliant, and the meals that you make are going to be a product of your own making. Now, if you have these three, the corn, the beans, and the squashes, you can make a multitude of different dishes. So you're not always eating salads or relying on these pouch meals. So by incorporating the traditional agricultural practices of the Native Americans into our research, we can find a sustainable path. So these three things do have a symbiotic relationship. The corn provides a trellis for beans, the bean roots fixate the nitrogen, and the squash has the big leaves that provides the cover from evaporation. So anyway, the whole point is that I'm going to do this as a blueprint for how we're going to survive in space. All right, so here's a UND Space Studies module. So one side is supposed to have a control bed with just earth, soil, and the bottom here is how we'd have the simulant bed. And the way it's set up is in just one strip. Now, the Native Americans actually did it in like plots, but we don't have that much space in the plant module, so I had to like narrow the focus. What here Mount Pleasant did, she went over corn, beans, and squash, and you can see we have a lot of amino acids and the vitamins and the energy, the proteins that we need, including water, from these plants alone. So eaten together, these three sisters form complete proteins, and that's going to be a big thing in space.